Greetings everyone and welcome to the next video of our channel from the series 100 Problems Around the World. And today we are in Honduras for Honduras Math Olympiad, the final mathematical stage, so the national phase of their mathematical Olympiad. The problem we are taking a look today have a statement as follows. It is given that real numbers a, b, c, and d are such that a squared plus b squared is equal to 1, c squared plus d squared is equal to 1, and ac plus bd is equal to 0. We are asked to determine all possible values of ab plus cd. In this case, if you have any solution to these nice systems of equations, please write it down in the comments. If not, let's take a look together to a possible solution. As you see, the solution we have thought about is quite short, and of course we rewrite the request of the problem. So we are given these real numbers, and we are who fulfill this system of equations, and we are asked to find what are all possible values of AB plus CD. Now, the two first equations of the system are very familiar for someone, let's say, who has who is passionate of mathematics and who has done mathematical competitions, because they resemble the main trigonometric identity. So sinus x squared plus cosinus x squared is equal to 1. So we can use this identity in order to let's say to see what comes out and how can we use it in order to find the value of ABCD. To do so, let's make, let's say, some substitutions, and let's say that sinus x is equal to a, cosinus x is equal to b, sinus y is equal to c, and cosinus y is equal to d. So from the first equations, we will get that sinus x squared plus cosinus x squared is equal to 1, and sinus y squared plus cosinus y squared is equal to 1. But from the third equation, we will get that sinus x times sinus y plus cosinus x times cosinus y is equal to 0. Now, we know that the left-hand side of this formula is equal to sinus x plus y. So from the third condition of the given equation, we will get that sinus x plus y is equal to 0. This means that the sum of angles x and y is equal to Pn with a certain number from integers, because for all sums x plus y which are equal to Pn, we get that sinus of Pn is equal to 0. Now, what the problem requires us to find is AB plus CD. So we want to find what is sinus x cosinus x plus sinus y cosinus y. Now, from this equation over here, given that y is equal to Pn minus x, we can substitute y in this expression, and we will get that sinus x times cosinus x plus sinus y cosinus y is equal to sinus x times cosinus x plus sinus Pn minus x times cosinus Pn minus x. But attention, because this expression over here, sinus Pn minus x times cosinus Pn minus x, is actually equal to minus sinus x times cosinus x, because in every case, if you could do some simple calculations for n from the set of integers, you will see that they both are, in this case, they both have let's say different signs. So if sinus Pn minus x is positive, cosinus Pn minus x will be negative, and vice versa. So we get that this expression over here is equal to minus sinus x times cosinus x, and substituting over here, we will get that this expression over here, who actually is equal to AB plus CD, is equal to 0. So we can finally say that AB plus CD is equal to 0, which is what we wanted to find in this problem. I'm pretty sure that there are other solutions to this problem, so I would be really glad if you could comment down the comment section what do you think of any other possible solutions. Thank you for your time, and hope you to see on our next uploads. Up to then, goodbye.